New City is designed as an online community, and it's designed for a virtual space. And when we started talking about the other space Odysseys, it wasn't the first time that we thought, because New City wasn't anywhere, it was online, it was like putting it in space. And it also is a virtual model of the entire population of the planet. So it really is like a planet. It's like a virtual planet or something. So the question was really, if you were to build a model of it as a physical model, which of course it was all modeled virtually, how big should it be? What should it look like? Where should it go? What information did we want to show? Because it also, it has architecturally designed urban spaces and buildings, but it also manifests itself as just information. So it was really just a question of how big should it be, what should it show, should you be in it or look at it? And I think finally the most difficult part is that it's dynamic. I mean, that it changes shape constantly. And also, you're never really meant to see all of it at once. You're always meant to see a location in it. So we had to freeze it. I mean, we had to take like a snapshot of it in a series of different states. You know, once with the whole thing, and other times with little samples of it.
So basically, did you take the movie, which was 3D modeling, and just freeze certain kind of frames from it and choose from among those to turn into models?
When we first conceived it, we had each one of these continents with a certain size, and that was really based on the area of the continent. And then how they related to each other was pretty arbitrary when we started. So we just picked a series of city intersections to make the joints between these different toroids, or these kind of donut shapes. And once we had that, then we just came up with some alternative scenarios where different cities would move through each other and connect. And that's how we generated the moving animation. Mm-hmm. But so it's true that this configuration just happens to be one of those scenarios, or one of those moments.
Okay. And how did you come to choose presenting them as pristine and white when in your film I think there's a silvery finish? Mm-hmm. How come you decided on this very perfect white shape?
Well, I'm glad you think they're perfect.
We'll talk about the imperfections later.
Well, there was a time where I was thinking it would be great to project on them, to put information on them, especially on this one, which is like a screen.
We were very nervous of like, I will.
Yeah. No, it's very difficult to get an image on it. I mean, you would really want to get an image on a surface from the interior or something like that. But so really, to me, they're like screens. Okay. I mean, right now they're like the blank screens that you would project the information on or put the information on, and so that's a little bit why they're white. I also think that because they're frozen in time, you know, they're almost like these fossils or something like that, like taken from another place where they're not alive anymore, but they're just these frozen artifacts. So I think also that was a little bit the look I was after.
And can you explain how these smaller models are details of this? I mean, I have the feeling that if we took a cross-section of it, it would be filled with spines on the inside.
So that's the idea.
That is
That's definitely the idea. Each one of these 4 pieces is like a core sample from this particular configuration. So you could actually find each one of those shapes in a little detail on that model. And these are 4 times the size of this. So they're very much enlarged.
Oh, sorry, go ahead.
Yep. And the difference is that, you know, New City, you can see in the video, it's very porous. So where there weren't these urban areas, we punched out volume, and so that you could get these vistas between volumes. And they also have very different densities of, of kind of building addresses. So, and by the way, each one of these little towers, each level is one address. So there's 9 billion levels if you were to take all of that texture and array it around the entire model. But so these models have those openings punched out of them, which this model doesn't. And they also have all of the little stacked up addresses, like little mini towers, on their interior surface, like this would have.
Okay. And can you tell us how physically they differ in the way they were made?
Sure. This model, they were both built in my office with, so there are definitely other ways they could be made. And in my office, we have a large table for routing material, like cutting material away. And this router moves on a gantry, and so it excavates material, but always from the top down. So you can only cut kind of what you can see. You can't undercut anything. So each of these pieces was divided into a maximum 10-inch depth and cut once from one side, and then flipped and cut from the other side. And then these 10-inch slabs were then glued together to make that model.
Okay.
Now, pretty much most of it, we could make each one of those rings kind of in 2 chunks. So, and then they all assembled together. And it's cut from foam, from, I believe, 8-pound foam, which is pretty hard foam, but still lightweight, and covered in a sealer that has a little bit of a structural quality to it, and glued with epoxy, and then painted with just house paint.
And there's no kind of armature inside of it?
There is, where these vertical supports go, we routed out a pad and inserted a piece of plywood, and then in the plywood is a threaded metal connector.
Right.
So the rods can unscrew and come out, and then when they attach to a metal fitting, and the metal fitting spreads the load across a little plywood pad.
And these smaller ones are made with a different process?
Yep, the smaller ones are built with a 3D plastic printer, which it has 2 cassettes of plastic. One plastic is just an ABS rod, like the size of a spaghetti strand, and the other is a reinforcing material to just hold the pieces while they're being built. And those run into a little oven, and there's a printing head that moves very similar to like a inkjet printer. And the metal comes out the head melts the plastic, and it draws the plastic in the pattern that you specify. And you get a block that can be about 10 inches cubic. So each of these models is built out of a series of 10-inch by 10-inch cubes. And then you put them into an electrosonic bath, and it melts away the reinforcing, and then you have a finished part. Then each of those finished parts along their edges have little doweled connections, and they all fit together with the doweled connections to make the complete rings. And we decided the exterior of them is covered in like epoxy filler and then sanded smooth. But on the side with the building texture, we did not fill those joints. So if you look, you can see these little hairline seams where all the different panels fit together.
Right. So there's no room for anybody to be intuitively sculptural when they're putting these together. It's all very determined by your design program and then the machines that act it out.
Yeah, hopefully. I mean, there's, in both of them, there's what I would call some fairing, meaning that, sanding with sticks and blocks. But no, they're pretty precise. The plastic ones in particular
You need
fit together pretty precisely.
And then the skinny little legs, which make them look like they're floating, which we also found kind of, they vibrate a little bit.
Yep.
Is that intentional, good luck, bad luck, that they move a little bit? Were you thinking about that aspect of them? And I'm sure it was quite a bit of engineering to make those tiny little rods hold the weight. As you said, you needed to put something in to distribute it.
Well, what I was most concerned with was, or is, moving them around, like shipping them. And right or wrong, we thought it was best to ship them on their bases floating so that we didn't have to wrap them, because all those little pieces in there are very, very fragile. So it's not like you can, fill it with something to reinforce it on the interior.
Yeah.
So those, they're metal rods, so they won't break. And if they vibrate too much, they could weaken the joints where they attach to the model. But, I think, I actually don't know. You know better than I do.
They did very well. They traveled well.
Okay.
there was not a problem with them, really.
Yeah, when we met with the Curator, who was also organized the shipping, we went through various options, and we all kind of agreed better to have them on these flexible pins.
One thing that I wanted to ask you, Greg, before you were speaking about imperfection, but what I found that is interesting is that, we have this one for New City, we have the big one, we have the other one from NOAA, and it seems to me that you decided, in a way, where is imperfection that is kind of taught, for NOAA, you always explain the project has like a ground, and so in a way we're not really working on the interior, because the interior will be the place where the things goes, where here, actually with all the focus on the interior, and then this you have this. So I really think it's also interesting the way you use the different way of doing the models, but also thinking, if I have to deal with imperfection, where imperfection is.
Yeah, it's also, these model techniques, as well as other ones, they really do have limits, and they really are good at showing certain things over others. I have to say we were right at the limit of the accuracy of those machines to make all of those kind of hair-thin towers, because it can only make so small a point. And it was very tough. I mean, Giovanna and Mirko know this already, but we actually burnt our machine up because it was building these 4 pieces. I know, we started it really early because I knew it would take, this kind of 3D printing is the fastest kind that does plastic. But each one of those panels takes 12 hours, I would say. And so there's, 100 panels here, so that's, 50 days of printing. So, and the machine was having to do these tiny little towers, so it's just going blip, 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 jumping around, doing a lot of moving. And I would say we were right at the limit of it in scale, and also in kind of intricacy of all the pieces. But the interior, the kind of fuzzy quality, was definitely what I wanted, and really only this technique could have done it.
Yeah.
I was hoping you were going to say they're not as fragile as they look.
Oh, they're pretty durable.
They're pretty durable. I mean, one of our concerns is, well, you wanted, of course, people to have an intimacy with them and not to have them covered in vitrines, and there's no ropes around them.
Yeah.
And so how do we balance that, the viewer's experience, with the possibility that somebody might touch something? They're very tempting.
Yep.
That they might break something off or get fingerprints. How do you feel about certain changes that might occur to them that way?
Well, it would be sad if somebody broke off pieces to take.
It would be very, very sad.
But I think the exterior of all the models could be pretty easily repaired. It's really just this interior surface of the 4 details. that's particularly fragile, and even then, it's not that fragile. And it's also pretty easily repaired because it's just ABS plastic.
Right.
So it's a pretty archival material. It's pretty durable. I think if they flex a whole lot, they might start to develop some cracks in the exterior where all these pieces were seamed together. But the epoxy filler we used, which is like a modeling filler similar to Bondo, it's pretty elastic, so it should move.
This large one did arrive with there's some hairline cracks along what would have been the joints.
Yeah.
And I don't know if that sort of thing over time might get worse, or with each travel it might get a little worse as well.
Pretty sure as it would travel, or if it went through big humidity changes or something, those cracks could come back. We used, the glue that was used for these is cycloanilate, which is a little bit UV sensitive. The glue that was used on these is an epoxy, which should be flexible and last a long
So you
time.
had to put UV light on these to cure the glue?
No,
or
no,
just the UV light coming from whatever lights were in your studio was enough?
No, it didn't use UV to cure. It's the cycloanilate glue, though, is real sensitive to UV.
It can change color.
Well, it would crack, it would get brittle.
Yeah.
So if you put a UV light on those from the inside, where those joints are visible, then it would get hard and it would crack. Although, to be honest, I think the filler around the perimeter would also probably hold the thing together, combined with the doweling. So I'm not so worried about that. This could develop those hairline cracks, and you wouldn't want to submerge it or something.
No.
Like those you could submerge. This one, the foam, the 8-pound foam is pretty durable. I actually don't know how archival it is. It's pretty sealed up now.
We'll have to find out what kind of plastic it's made of.
Yeah.
We didn't talk about the other models for the Divide film. Are they made in the same process?
Exactly the same as these.
Yeah. Although that you made those, well, actually you made them all just recently for our show, even though that's from a project from 2004 and this is from a later project.
Yeah, one of the two was built a couple of years ago, just to take a look at it for kicks for the writers. But we never really finished it up. Then the other one we printed especially for the show.
Do you see them as works of art, or as illustrations of your idea, or models, or what are they to you?
They're architectural models. And I think they're process models. I mean, for me, it's the Divide models especially, we'll go back and change the design based on having built those models.
So it's not finished, the process.
Yeah, I really see them as architectural models.
And this, in a case, I'm curious, in a case, the film will be done, and at one point it's like the model serves actually to then produce a digital, or
yeah, it
will
would
not
be.
have like a Hitchcock use of something that will be filmed as if it will be like that you will really film the model and then transform it?
No.
No.
No, we would build sets
Yeah.
like we built this model.
Okay.
That's what happened in Minority Report.
Okay.
So there was a digital set, and then there was a physical set. Two things pretty much corresponded. And I'm sure for Divide it would be that way.
So there is always like a back and forth between the digital model and the physical model. Like here, in New City, you pass from like a digital model to you wanted to do the physical model, where there you had a digital model, you have a physical model, then you will return to something that I think that is like in the movie will become like.
Yeah, I think it would be CGI primarily. It would all be computer graphics.
Yeah.
And can you tell us what computer programs you used for these, to design these?
Yeah, I think for all of them, really just two. Well, no, three, I guess. They're all designed in Maya. All of the towers are designed writing scripts in Maya. And some of the information for those scripts went through Excel, but most of it was just native in the Maya, the algorithms that modeled all of it. So, you know, a person, actually I personally modeled these, and then the buildings were modeled by Mikhail in my office, who wrote scripts for them. And then I'm pretty sure in all cases they went directly from Maya to the 3D printer. But sometimes we use a product by Materialize, which cleans up that geometry for the printer, but we didn't need to do that with these. And then this model was also same model from designed in Maya, and then it was separated into the layers, and a tool path was generated using a secondary program called SurfCam. And what that does is it just takes the geometry of the design and translates it into the movement of a tool, which runs the CNC mill.
And you have all of this computer-controlled equipment in your lab, or for certain projects, do you have to take a project outside to somebody else who has equipment?
Well, usually what we'll do is build prototypes and models and things like that in the office with a CNC mill. But then when it comes to building, like say, like if it's a custom piece of furniture even, like some of the built-in stuff in the Bloom house, we go to somebody else with a mill just because it's so dusty and noisy, and we try to use it just to solve the design, but the actual production, we try to go to somebody else. For the printing, you know, we have one machine in the office, and it, you know, it can do what it needs to get, what it can, and if we need more than the bandwidth we have with the one machine, it's real easy to find. It's like a Kinko's or something. There's a lot of people that have those machines that you can send things out to.
Yeah. Even though these are, in a way, they're prints, but it's not something where you would say in many years to come, oh, the thing is deteriorated, we'll just reprint it. Maybe because it took too many hours to print. Do you consider it as an object, something in itself that is unique and should be preserved, frozen, as we talked about an artifact being frozen?
Yeah, in my experience, the reality of it is that the digital files and their ability to be read and the method of constructing the models moves quickly enough that the model will outlast the ability to rebuild it.
Certainly something we're dealing with here.
Yeah.
And
So
we want to improve it.
Yeah, it's not like having a digital file of a section of a drawing that you could imagine to, like, in 2 years after we.
Although even that in 10 years, who knows?
No, in 10
We can
years,
read
yes,
it.
but.
yeah.
Yeah.
Yeah, I think there are things that we, you know, I know there are things that we even use the same mill to manufacture, that if I went back and tried to read the code that ran the machine, it's all changed.
Yeah.
And so I think these models there's no reason they wouldn't last 30 years, and there's no way that you could reprint them in 30 years.
No.
So, thanks a lot, Greg.
Sure.
I think we have a great insight now.
All right.